So today lecture we will use Cutnell Johnson book in chapter 27 about interference. We will use mainly from this book, so we will discuss about this book. So today we move to chapter 27. This is about interference and the wave nature of light. So this is mainly about this interference and how the beauty of interference we will discuss mainly in this chapter. Okay, the beauty of interference coming from this concept, as you know, if there are two or more light, so we focus only two here. If you have two wave, this source and this source, they have different something. For example, electric field. As you know, electric field is coming from wave, yeah, fluctuate. For example, they have wavelength like this one, and the source, the other source, wavelength like that. As you can count easily, this is one, and this is two. Yeah, this is one, and this is two, and this is 1/4. So it means the wavelength is 1/4 wavelength. Yeah. And the second source, you have 1/4 lambda. So this is 1, this is 2, this is 3, okay, and this the last one is 1/4. So you have source 1 and the second one like this, and you see here actually they have constructed interference because this is additional. Yeah? So the wave emitted by source start out in the phase, even they have different phase. Yeah? For example, this is source 1 and source 2. They have different distance. Yeah, you can see they have different distance, and you have L2 minus L1 equivalent like this one. This is superposition. Superposition is mean additional two wavelength. This plus this, it's become constructive. It's mean a constructive interference. Okay, let's continue. This is the principle. So every time you can find lambda, and m could be 0, 1, 2, 3, and something like that. But you can see another one. You have source number, the first source and the second source, they have different 2, 3, 4 wavelength. You can count this one, 1, 2, and this is not 1 but 2/4. Okay, and the second one you have same length, 1, 2, sorry, this is 2, this is 3, and this is 1/4. Okay, but you can see here clearly it looks like cancel out one each other. Okay, so we call it destructive interference. So if this wave plus this wave, yeah, every point you can see cancel out one each other. So this is the result will be 0. So we call it destructive interference. Yeah. So if the difference like this, the result like this, we call it destructive interference. Okay. Okay, let's continue. Okay, so superposition it's mean addition two wave or more wave, and you can see here. If you see in this point like this, yeah, this plus this, or the different L2 minus L1. How about the result? This one. Okay, this is destructive, so you can check here destructive. And if you have L2 and L1 like this, and the difference is 1 lambda 3 over 4 minus 2 over 4, it's equivalent 1 lambda, and you can see 1 lambda it's mean constructive. If constructive or destructive interference is continue occurring a point in this point, in this point, and in this point, okay, the source of wave must be coherent sources. It means coherent sources. Two sources are coherent if the wave they emit maintain a constant phase relation. Okay, and let's continue. So there are beautiful experiment. We call it young double slit. This is very interesting, and the experiment is very simple. If you have light source here, this is light source, single wavelength, for example green, blue, red, or something like that, and go to single slit. This is slit, only one. Okay, this is slit. They have one slit, they have double and we after one slit we go double slit. This is single slit, and this is double slit. Double slit, it's very interesting here. Double, yeah. 1 and 2 slit, and very interesting. You can find in the screen, yeah, the pattern like this one in the screen. Yeah. In Young experiment, 2 slit act as coherent source line. Light wave from the slit interfere constructively and destructively on the screen. This is the screen, yeah, and you can see this is constructive, this is destructive, constructive, destructive, constructive, destructive, until the right side, and for the left side also same, yeah, like this one. This is very interesting experiment, and people try to explain about this experiment. Okay, we can go to the next page. Okay, okay, let's go to this screen. If you have two sources, one source is S1 and S2. First, let's see on the screen here L1 and L2, and you can see L1 equivalent L2. What happens if L1 minus L2, same length, and become 0 lambda. This is will be constructive. Sorry. Okay. So you can find the bright fringe will occur here. And actually you can find in any location based on S1 and S2. For example, the difference is lambda here. So you can find L1, the length here is L1, and you can find L2, this is the same like this one, okay? And additional this one with lambda. So it means L2 is L1 plus lambda. How do you expect this one? Yeah, the difference is lambda here, and you can expect here will be bright fringe. This is bright fringe. Okay. What happens if the difference, this is L1, this is L2, and additional this one is half lambda? What will be happen? You can find the difference is this one, its mean will be dark fringe. So you can find easily the difference based on the formula. Yeah? If the formula 0 lambda and lambda, 2 lambda, 3 lambda, if the difference is like this, you can find it will be constructive, or it will be bright here. Bright, dark, and so on. Okay? Is that clear? Okay, let's continue. Okay, from this experiment, you can expect here what will you expect? Okay, in the center, it means in the center, or it means 0 fringe. You can expect here will be bright. Okay, this is bright. Okay, you can find this one, and here you can find dark. Why dark? Because here it's destructive, cancel out. Two wave cancel out one each other. Okay, and the next, this is, it will be bright. So it means this is the main in 0, and this is the first bright, second bright, third bright, fourth bright, 5 bright, and so on. To the right side. To the left side, it will be similar. Yeah? This is the first, this is the second, this is the third, this is the fourth, 5, and so on. It will be same. Yeah? You can find this is the 0, the main, this is the first, this is the second, this is the third, the fourth like this. Yeah, this is the first, the left side, second, third, the fourth. You can see like this. Yeah, so the brightness will be here, the second, the first bright, the main, the first, the second, the third, and so on. Okay, is that clear? Okay, let's continue to the next slide. Okay, what happened from this experiment? You can expect double slit experiment. This is the first source, and this is the second source, and the distance between S1 and S2 is D, like this one. Okay, so as if for the distance it's much more distant L than D, so you can cut here. Actually, yeah, this long like this and this is long like this, yeah, but we cut here, so it looks like parallel. Okay, L1 and L2 looks like parallel. They have same angle with theta here. Okay, and you can expect here, if this is similar theta and theta, okay, and you can expect the difference is delta L. Okay, do you agree? If you have a triangle like this, okay, if this is 90 degree, so the difference is only this one, delta L. Okay, so how about the delta L here? Delta L, it's mean if you find the angle like this, so this to this it will be sine. Do you agree? You have delta L here, and sorry, you have delta L here and you have D here, so delta L over D, how you call it? Sinus theta. Okay, so it means delta L equivalent D sin theta. Okay, so now you have very simple formula. The bright fringe of a double slit, you have double slit, okay, it will be every time sine, yeah, because this is actually D and D coming to here. Okay, okay, so delta L, okay, D is sinus theta, and every time it's multiplied by M. Okay, so you can have lambda over D is for the first is 0, the one is, so it's mean lambda over D, sorry, and this is lambda over D, and this is 2 lambda over D, 3 lambda over D, and so on. Okay, and you can find dark side, dark fringe of a double slit if like this one. Yeah, so this is every time M, this is every time M plus half. Yeah, M plus half, every time M plus half you can find the fringe. So now it's become very interesting. Yeah, the formula, you can find the bright fringe and the dark fringe. Dark fringe every time M, and dark fringe every time M plus half. Okay, now it's become very simple equation. So you can expect in your screen here, this is the very bright here in mine, and this is the first bright, the second bright, the third bright, fourth, and so on. In the same time to the upside, the first, the second, the third, and every time in between you can find the dark side. Yeah? The first dark side, the second dark side, third, and so on. Yeah. Is that clear? Okay. And then let's continue to here. Okay, now let's check by example. If you have young double slit experiment, yeah, always remember double slit experiment. If you have double slit experiment, you have two potential answer, the bright and the dark. Okay, if you have red light with this 664 nanometer is used in young experiment with slit separated by its mean D, this one. Yeah. You have this slit and you have this light, and in between you have D with 0.00012 meter, so it's mean 1.2 like this one. Okay, so it's become new source. Okay, new source. Okay, you can find in the center in the main, yeah, like this. It's also like this. You can find it must be the main bright in the center here. Okay, the screen is located a distance. This is the distance from the slit. Find the distance on the screen between the central bright fringe and the third order bright fringe. Okay, the question is try to find the distance. It's mean y. Yeah, the distance from bright fringe to the third order, the main bridge to the third order. Yeah, this is equivalent to the up and to the down, I mean, like this. It will be same. Yeah, you can get same distance here between this to this and this to this. Okay, so the main question is what the distance for the y. Okay, this is the question. Let's continue. Now it's become very simple. You can start from find the theta from the formula, because this is the bright fringe. Yeah, sinus m lambda over d, and you can find this is the third bright, and you can find the lambda from the problem, and d like this. So you can find the theta is this one. And how to find the distance, because the question is the distance here. So the distance you can find the tangen. Tangen is mean y to L. Okay, you can find tangen is tangen theta, it's mean y to L. Okay, so y it's mean L tangen theta. L tangen theta. So you can find L from the problem here, like this, and tangen theta you can find the angle this, and the answer is y is like this one. Okay, is that clear? So you can find easily based on this formula which question. That's right. Okay. Okay, this is a little bit conceptual. White light. White light is mean composition from many colors and young experience. This figure show a photographic that illustrates the kind of interference fringe that can result when the white light is used in young experiment. Why does young experiment separate white light into its constant color? Okay, you can find this. In any group of color fringe such as the two single out, white is the red farther out from the central fringe, then green is white is the central fringe white. Why this is white. Okay, so you have the answer from this. Okay, so I'd like to stop the lecture until this one. So please understand about this problem, and thank you very much.